So today we're going to start chapter 6, section 1, and we're going to today cover the perpendicular bisector part of the notes. So first thing we're going to do is define what a perpendicular bisector is. And a perpendicular bisector can be a segment, a ray, a line, or a plane that's perpendicular to a segment at its midpoint. Now on the next slide, we need to understand what the word equidistant means, and that means the same distance. So notice in my figure here, what's being bisected must be a segment. So the piece that's being bisected in this picture is the segment AB. Notice the perpendicular bisector is CP. So CP is the perpendicular bisector of AB. And AB is a segment. So what's being bisected must be a segment. It can't be a line, because when you bisect something, it makes two equal parts. So notice when this was bisected, notice the length of AP is the same length as PB. Now, next, we're actually going to see the perpendicular bisector theorem. And what this states is, in a plane, if a point lies on the perpendicular bisector of a segment, then the point is equidistant, and this is where we needed to know what this word means, which means the same distance, from the endpoints of the segment. So here it's stating, they're taking this little paragraph and they're writing it based off of this picture. If CP is the perpendicular bisector of AB, then that tells me that CA is going to be equal to CB, because point C is on this perpendicular bisector. There's a point on it, so then it's equally distant from this endpoint as it is from this endpoint. That's what this theorem states. Let's say I added another point down here. Let's say I called this point D. If I were to draw a line to each of the endpoints, these segments would also be equally distant because it's on the perpendicular bisector. So if point D is on that perpendicular bisector, then that would tell me that AD equals DB. That's what the theorem states. Next, we're going to see the converse of the perpendicular bisector. Again, remember the converse switches the if and the then. So now, instead of them starting out, we're going to be shown that they're equally distant. So in a plane, if a point is equally distant from the endpoints of the segment, then it is on the perpendicular bisector of the segment. So here, if DA is equal to or congruent to DB, then I know that point D is going to be on the perpendicular bisector of AB. Remember, you can take this perpendicular bisector, it's a line, and you can continue it, and you could see that point D would be on the perpendicular bisector. So if they told you,
This is like the other way around.
correct, it's the converse. They just switch the if and the then. Now there's several statements that I could make based off of this picture. By looking at this picture, I could say that point C lies on the perpendicular bisector of AB, and I could show from here to here and here to here, and I could put some congruency marks and show that it's equidistant from the endpoints because it's on the perpendicular bisector. I could also state that instead of saying point C lies on the perpendicular bisector, I could change this letter and I could also say from this picture that point D lies on the perpendicular bisector of AB, again, because of these congruency marks. Because they are equidistant from the endpoints, I know that D is on that perpendicular bisector. I could say the same thing for P. I could also change this letter and now say P lies on the perpendicular bisector of AB, because notice it's same distance to the endpoints. Another statement you could base off of this picture is you could say CP is the perpendicular bisector of AB, because you can see the right angle here, and you can see that it splits it into two congruent pieces. So it's perpendicular because it's got the right angle, and it's a bisector because it split it into two equal pieces. Now we're going to just do some examples using these two, the perpendicular bisector theorem and its converse. So let's try the first example. I know it's kind of hard to see, but it's stating here in the black writing that BD is the perpendicular bisector of AC, and it wants me to find AD. Well, I know because of my perpendicular bisector theorem that if a point, and this point D, if it is on the perpendicular bisector, and they told me it in the beginning, that BD was the perpendicular bisector, then I know that any point to the endpoints, the distance is going to be the same. It's equidistant. So I know that CD, let me do it in a better color, CD and AD are the same. So I can set up my equation and I could say that 3x plus 14 equals 5x. I'm going to move my x's together. I'm going to solve for x, divide by 2, and x equals 7. Now the question did not ask me to find x, it asked me to find the length of AD. So now I'm going to take what x equals and plug it in. So AD equals 5x. If I put a 7 in for x and multiply it, the length of AD is 35. Pretty good? Okay, let's just try 3 more examples, basically doing the same thing. Anybody still need this slide? Sorry, I'll go back. Okay. Okay, so again, it's asking us to use the perpendicular bisector theorems. For the first two, I'm going to use the perpendicular bisector theorem. For number 3, I'm going to use the converse. So I'm going to go ahead and label what's given to me. So it told me that ZX is the perpendicular bisector of WY. So notice it's got the little right angle. So that tells me that these are also equal because WY has been bisected. I also know by the perpendicular bisector theorem that if there is a point that is located on the perpendicular bisector, which is point Z, then it's going to be equidistant to the endpoints. So WZ is going to be the same, or it's equidistant to ZY. Now I'm going to go ahead and label, because they actually gave me the measurement of YZ, and YZ is 13.75. It wants me to find WZ. Well, I've already labeled it with congruency marks. By using my perpendicular bisector theorem, I know that WZ is equal to YZ, so this side is also 13.75. Because they're both equidistant from that point on the perpendicular bisector to the endpoints. Now I'm going to use the same picture. I'm going to change colors. So I did number 1 in red. Now let me do, instead of erasing, I'll do number 2 in blue. So again, same given information that ZX is the perpendicular bisector of WY. This time they're giving me expressions for the lengths of WZ and YZ. So now instead, I'll cross off the red. So now they told me WZ is equal to 4n minus 13, and YZ is equal to n plus 17. Now because the given was the same, these two segments are still congruent. They're still equal. So in order to find the length of YZ, I need to find the value of n and then plug it back in. So let me go ahead and set up my algebraic equation. I'm going to set 4n minus 13 equal to n plus 17. Doesn't matter which one you write first. You're just setting the two segments equal to each other. I'm going to go ahead and combine my variables. 3n minus 13 equals 17. I'm going to add 13. I get 3n equals 30. Divide by 3, and n equals 10. Now again, it did not ask for n, it asked for the length of YZ, and we were told that YZ equals n plus 17. So if I plug in 10 for n, I can see that the length of YZ is 27. Now, notice this time, they're giving me numbers for all the sides. They're not telling me that ZX is the perpendicular bisector. So now I'm going to go ahead and label my picture now with all these numbers in black. So let me just cross off the blue. So WZ equals 20.5. WY, this whole piece down here, equals 14.8. And then this side over here, the YZ is also 20.5. For this question, I'm going to use the converse of the perpendicular bisector. So this states that if a point that's if a point is equidistant from the endpoints of the segment, then it's on the perpendicular bisector. So because these two are the same, 20.5, so because we could, if we had to explain, we could say here that because WZ equals ZY, I know that ZX is the perpendicular bisector. So then that way I know that I could just split this into two equal parts. I could either show that WX I could say that it's the same. So I could, let me just do it this way. So I could say WX, 2 times WX equals WY. Well, WY equals 14.8. So 2 times WX divide. And WX, which is what I was asked to find, is going to be 7.4. Now, if it does not ask you to explain, if it only asks you to find Wx, all you needed to do was divide 14.8 by 2.
You don't have to show it like the equation, you can just do 14.8 divided by 2.
Correct. If it just asks you to find it, that's all you would have to do. But if it asks you to explain, you would be telling me that you were using the converse of the perpendicular bisector theorem, and you would show that WY was split into two congruent pieces, and that's why you were dividing by 2. All right, so this is where we're going to stop. Your homework tonight is only involving these two theorems, the perpendicular bisector and its converse. There are 9 problems. I know some of them are evens. We will go over those answers tomorrow in class, and then we'll finish up the notes. Tomorrow we will do the angle bisectors. So 9 problems for homework. So you can go ahead and you have about 7 minutes. You can go ahead and start on it. And if you get stuck on anything, you can ask me. Pretty good?